Hello, everyone, and welcome once again to STEM Sunshine 242. Today, we would like to conclude our series on number theory with this third lesson. Firstly, let's take a minute to recap what we discussed in lesson 1. So, in lesson 1, we talked about different types of numbers. In particular, we talked about the set of natural or counting numbers, the set of whole numbers, the set of integers, the set of rational numbers, and we talked about the set of irrational numbers. And we said that these different sets of numbers are all subsets of the set of real numbers. So today we would like to build on this first lesson by showing that each real number corresponds to a location on the real number line. Also, we would like to compare numbers using inequality symbols and graph inequalities on the real number line. So let's begin. In this diagram, we see a portion of the real number line between the numbers -4 and +5. When we move to the right of 0 towards positive infinity, we are said to be increasing in value. Conversely, moving further to the left of 0 gives us a decrease in the value of whatever quantity we are discussing. So let's see if we can put this concept into practice. Here we have 7 real numbers: the positive square root of 3, positive 3.5, -3/4, positive 1/2, positive pi, 0, and -3. Each of these numbers can be located on this number line, and then by doing so, we can organize the numbers in ascending order from left to right. So let's begin. Let's start with the positive square root of 3. Now the square root of 3 is an irrational number and is approximately equal to 1.73 to 2 decimal places. It is between the numbers 1 and 2 on the number line, but closer to 2 than to 1. So let's place it here. The number 3.5 is halfway between 3 and 4, so we would like to place it here on the number line. -3/4 is a negative number, so it goes on the left side of 0 and is between the numbers 0 and -1, but closer to -1 than to 0, so we will place it here. Positive 1/2 is halfway between 0 and +1. We will place it here. The number pi is another irrational number and is approximately equal to 3.142 to 3 decimal places. So we will place it between 3 and 4 on the number line, but closer to 3 than to 4. 0 would obviously go here, and -3 will go here where -3 is. Then, if we look at our number line from left to right, we can arrange the numbers in ascending order. Thus, our answer is -3, -3/4, 0, 1/2, square root of 3, pi, and then 3.5. Let's try another example. In this example, we have the numbers square root of 2, 1.6, -3/4, 4/5, e, and -2. As before, we plot the first number, which is the square root of 2, on our number line. Now the square root of 2 is an irrational number and is approximately equal to 1.142 to 3 decimal places. So we will place it just ahead of the number 1. Next, we will have 1.6, which is halfway between the numbers 1 and 2. -3.4, which is equal to -0.75, is between -1 and 0, but closer to -1. 4/5, which is the same thing as 0.8, is between 0 and 1, but closer to 1 on the number line. E is a mathematical constant, commonly referred to as Euler's number, and it's approximately equal to 2.72 to 2 decimal places, and it's between 2 and 3, but closer to 3 on the number line. And finally, we have -2, which goes here. Now reading once again from left to right, we can now place our numbers in ascending order. We have -2, -3/4, 4/5, square root of 2, 1.6, and e. Now let's take a minute to look at inequality symbols. You may have heard of mathematical equations where one expression on one side of the equation is equal to another expression on the other side of the equation. Well, inequalities use other symbols to show the relationships between mathematical expressions. These symbols are greater than or equal to, less than or equal to, and not equal to. Now you may be wondering, why do we need these symbols? Well, as we previously stated, we use them to compare expressions. What if, for example, someone, and let's call this someone Tim, has $50 in his pocket. And then Tim goes to the store and spends an unknown of money. So how much money is he left with? Well, we don't know exactly, but we do now know he has less than $50 in his pocket. So we can write an inequality to show this. We can say that Tim has an unknown amount of money X in his pocket, which is less than $50. We can also use these inequalities to compare real numbers. For example, let's say we have two numbers, 3 and 7. Let's plot these on the number line here. 3 goes here, 7 goes here. We can therefore see, reading from left to right, that 3 is less than 7, or we can also say that 7 is greater than 3. Let's try another example. Let's use the numbers negative 1/2, and negative 3/4. I'll give you a few seconds to try this one. Time's up. Let's see what our solution is. Now, the number negative 1/2 goes here on the number line, and negative 3/4 is close by. It goes right here. Reading from left to right once again, we see that negative 1/2 is greater than negative 3/4, or negative 3/4 is less than negative 1/2. I hope you got the exact same solution that I got. Another thing we would like to discuss is how to graph inequalities. Let's say we have an expression, x is less than negative 1, and we would like to represent this on a number line. We start by identifying negative 1 on the number line, and then put a small circle above it. Then we draw an arrow to the left indicating that x is less than negative 1. Another example would be if we wanted to graph the expression x is greater than positive 3. To do this, we would have to identify the number positive 3 on the number line. Then, like we just did, place an open circle above it. Then we would draw an arrow towards positive infinity, and this would indicate that x is greater than 3. So any number we can think of that is greater than positive 3 would be a solution to this inequality. That means x can be 3.000000000000001. It can be 4. It can be 1095. It can be 1 million, etc. Any number we can think of, as long as it's bigger than positive 3, it will be a solution to this inequality. But what if we had the expression x is greater than or equal to positive 2? How would we graph this? Well, for starters, we will notice that the inequality symbol preceding the number 2 is a greater than or equal to, and not simply a greater than symbol. So what we would do in this instance is firstly identify the number positive 2 on the real number line. Then we will place a closed circle above it. Once we have drawn our closed circle, we will complete the graph by drawing the arrow towards the right. Now, in the next example, x is less than or equal to the positive square root of 3. Why don't you take a few seconds and do this one? Pause the screen if you have to. Time's up. Let's review our solution, shall we? Firstly, we notice that x is less than or equal to the positive square root of 3. So we would have to use a circle above the positive square root of 3 on the number line and then fill it in. Then we would draw an arrow towards the left, like this. There you go. Now I hope your solution was the same as mine for this problem. Now, what if we have an expression where the variable x is between two numbers, such as this one, where x is said to be between -1 and +2? Now, in order to graph this expression, we should firstly identify -1 on the number line and place a circle above it. But we don't fill it in. Then we will locate 2 on the number line and put another circle there, and we don't fill this one in either. Then we draw a line connecting both circles, and this is a graphical representation of this inequality. Let's try one last example. The variable x is greater than or equal to the negative square root of 2, but less than the positive square root of 3. Now, in order to graph this expression, we firstly identify the negative square root of 2, and because x is greater than or equal to it, we place a circle above it and fill it in. Next, we identify the positive square root of 3 on the number line, and we place a circle there, but we don't fill it in. And finally, we connect both circles with a line. And this completes our graph of that particular expression. So let's quickly recap what was discussed today. We said that we can create a number line called the real number line, where we can graphically represent all real numbers. We can also use this number line to arrange numbers in ascending order. We also said that numbers further to the right are greater than those to the left on the real number line. We also said we can use inequality symbols like greater than, and equal to, less than or equal to, or not equal to compare real numbers. And finally, we were able to use the number line to graphically represent, that is, inequalities. So that concludes this lesson and the series on number theory. As always, if you enjoyed this presentation or found it informative, please like the video and don't forget to subscribe to the STEM Sunshine 242 channel. Thanks again for watching.